now that I'm all hyped up, I hope that I can deliver. My clicker just stopped working, so we'll make do with that. Thank you so much for coming. My name is Daria Caraway, and my talk is on how to have an amicable breakup with your JavaScript library. A little bit about me. I'm currently a software engineer at Workday in my hometown of Boulder, Colorado, where I live with my cat, Odin, and I like cats a lot, so you'll see. Now I want to talk to you all about something that I think many of us experience, which is dating and JavaScript libraries. Now I find that choosing a JavaScript library is a lot like dating in that the longer you commit yourself, the messier it is when you decide to break up. In my experience, I've seen a lot of JavaScript relationships that look something like this. You first find that library, you fall in love, and you enter the honeymoon phase. You see all the ways that the library is going to make your code cleaner and faster and stronger, and you begin to use it everywhere. You start to use it so much so that you become attached at the hip. Maybe you're importing it in hundreds of files, you're using it for a variety of functionality, and before you know it, you've basically opened up a joint banking account because whether you like it or not, your code is now completely dependent on this library. And this whole time you're thinking, wow, what did we do before we had this library? Our lives are so much easier now, this problem is solved, we never have to think about it again, what could possibly go wrong? And then it happens. You gotta break up with that library. Now there's so many different reasons why we have to break up with JavaScript libraries. Oftentimes product needs change and the library you're using is no longer fitting those needs. Maybe they actually broke up with you and the library is being deprecated. Raise your hand if you've ever had to break up with a JavaScript library in a piece of code that you've used. Yeah, wow. It's very common because the JavaScript community is so incredibly fast-paced. And what do we usually do when this happens? One behavior that I've seen is that people will just try to completely move on. They'll take the time hit up front to remove the code all at once, get rid of the library, and make a clean start. But if you were in a long-term committed relationship with that library, that's going to take a lot of time and a lot of convincing of managers or product owners that it's worth that time right now to get rid of the library all at once. Another behavior, that's my personal favorite, is when you ghost the library. So this is when you say, like, it works if you just leave it over there and like put a comment that says don't update this library, and you close all the files and never look at it again, it should be fine. But you never know when your product owner is going to come back to you and be like, hey, Daria, I think it'd be a really cool idea if we could add a feature over in that code over there. And that ghost comes back to haunt you. The last and probably the most common behavior that I've seen is when teams will try to remain friends with the library. So this is when you say, it's okay if we leave it, but if you ever touch a piece of code that's using that library, go ahead and take it out, and we'll phase it out of the code base piece by piece over time. And this is probably a good compromise between short-term and long-term trade-offs, but it also leaves your code quite fragmented and really difficult for newcomers especially that are coming into your code base. They can't discern a singular pattern, and it can get pretty messy pretty quickly. So how can we better prepare for these inevitable future breakups? For me, I like to start out all new JavaScript library relationships with a concept that I call speed dating. This is where you prototype out multiple libraries early in order to make a more educated decision before entering into these relationships. But because breakups are pretty much inevitable, I also want to walk through a technique that allows us to easily bail on bad relationships, which to me means being able to quickly switch out libraries without sacrificing code clarity or maintainability. And lastly, I want to talk to you about testing and what it looks like to write useful tests that won't break when we change the underlying library implementation. Again, I like to start out all new JavaScript library relationships with this concept of speed dating, where you prototype out multiple libraries early in an integrated environment. And I find that speed dating gives us a couple things. For one, speed dating allows us to get to know the dating pool of JavaScript libraries out there, and each library a bit more intimately. It's more in-depth than reading the documentation or playing with the demos, because you're actually going to build a prototype that's integrated into your application. And you can get a really good feel for things like the public API and how does it interface when it's integrated into your environment. And you're going to do a little market research with this dating pool of JavaScript libraries. You can see how different libraries compare and contrast to each other. How are they similar? How do they tend to be different? Why do they tend to be different? And my personal favorite part about speed dating is while you're prototyping out these libraries in your own environment, you can take some time to look at the source code of these libraries, and if nothing else, just learn. Learn about how their developers are implementing design patterns or how they're solving similar problems in your ecosystem, and figure out why they're doing it, how they're doing it, and maybe apply it back to your own code base as well. The other half of speed dating is that it allows us to get to know ourselves. What are our expectations around customization and performance? And we've done all of that market research, the dating pool research. What of all those features that we found that are out there does our app need now, but also potentially in the future? And because you've been building these prototypes that are already an existing representation of what it'll look like in your environment, you can use those prototypes to socialize these different libraries with your team members, talk about the pros and cons, socialize new features that you found with product owners or designers, and everyone can make a more informed opinion. So you've gone on a variety of speed dates, and you think you found the one, and everyone can make a more educated decision about what type of relationship you want to engage in. And I know this won't ease the pain of a breakup, but it'll hopefully make it so that we don't have to do it as often, because we've chosen these libraries to fit our future and also our current needs. But because breakups are inevitable, ideally we want to be able to bail on bad relationships, right? We want to be able to quickly switch out libraries without sacrificing code clarity or maintainability, like in a lot of those behaviors I mentioned earlier. And here's where I want to introduce the idea of wrapper components. So you can think of these wrapper components like a prenuptial agreement between the rest of your code and this particular third-party library. Now that we know what our application needs, we can create a contract to fit our application's use cases and normalize that interface into a wrapper component. And this wrapper is going to be your protection for future breakups. Now, what exactly does that look like in terms of code? Well, third-party libraries, there's some sort of entry point, whether that is a function signature or a class constructor, and enforcing that entry point can be done in a variety of ways. My personal favorite is with TypeScript, and I'll show you how to do that in all of my examples. If you're using React, you can take advantage of React prop types. And if you're not using a typing system, it gets a little bit trickier and potentially less binding. If you are following a similar model and not using a typing system, feel free to contact me on Twitter and let me know how, because I think it's a really interesting problem. One suggestion that I have is to use something like JS docs, so at least you have like a written down contractual explanation that lives and breathes with the code itself. So I have this demo app. It allows you to discover cute adoptable pets in the Seattle area, and all of the pets on here and in my app were adoptable as of last night. So if you find a really cute one, feel free to check out the Seattle Humane Society. Right now, the app is using a React component library called Grommet for all the button components, and an HTTP library called SuperAgent to make HTTP calls to a Google Cloud function that I have that's serving up these cute pets. And the functionality is pretty simple. So you can fetch a random pet from the button, you can add it to your favorites on the right in the cards, and then you can also clear your favorites. Taking a closer look at all the buttons on my page, I've written a button wrapper around the Grommet component button. So on the left here, you'll notice I have the interface for my button wrapper component. And if you're not familiar with TypeScript, this is a fairly binding contract. It's that prenuptial agreement that I mentioned earlier. If you try to pass in something that isn't on this list, you're going to get a compilation error. If you don't pass in the required onClick handler, you will also get a compilation error. On the right, I have my actual React button wrapper class component. If you're familiar with React, I know this is not the latest and greatest way to create your components, but I figured it'd be more relatable for everybody else. If you're not familiar with React, all this class component does is it has a public render function. The return value of that render function is whatever you want to render on the screen. So in this case, it is the Grommet button from the Grommet library. And I'm passing in all the props that my button wrapper takes in as props as well. And the Grommet button itself is fairly customizable because people want to be able to use these third-party libraries to do like a variety of things to fit their different needs. It has dozens of props, but I know that all of the buttons on my page are going to look similar to this button here. They're going to have either an icon or a label or both. So I've gone ahead and put that in my prenuptial contract. Now, this makes it really easy for developers moving forward, right? They don't have to go to the Grommet website, read all of the documentation, figure out what all the props mean and do, and how to use them, when in reality, all they probably want is a button that looks and feels like all of the other buttons on my page. So I can standardize that behavior that I want for my application and normalize that into my wrapper interface. And because I did quite a bit of speed dating while I was putting together this talk with a lot of libraries that have button components, I know what tends to be similar between them and what tends to differ, especially when it comes to the button's public API. I can figure out why different libraries have developed their public API in a certain way, and which one I want to apply to my button wrapper component. For example, on the left here, I have that same button wrapper around the grommet button component, and you'll notice that the icon and the label for this button get passed in as props with all of the other inputs on the button. On the right, though, I have a wrapper around Material UI button. Material UI is another React component library built on top of Google's Material Design. And the Material UI button actually takes the icon of the label in as a child component of their button. So the way that this works is whatever you pass in as the child to the Material UI button, Material UI is just going to take those components and just render them inside of the button. It doesn't have to be an icon or label. It can be whatever child you want, and it's just going to get rendered inside of their button. So it's quite a bit more flexible compared to the more discrete method of passing the icon and the label in as props that the grommet button accepts. But the really cool thing about these wrappers is though the internals of my components have changed ever so slightly because the libraries have dictated such, the actual contract, my prenuptial agreement that I've contracted with the rest of my application doesn't have to change, which means that I'm free to uptake whichever third-party library, and it doesn't matter how they want to implement it. I won't have to update any of the consumers of my button wrapper, which is really great. And this technique also works for services or utility libraries. It doesn't have to just be for components. I've written a wrapper around SuperAgent to make get and post calls to and from my Google Cloud function. And in this example, the contract is just the function signature, and it's pretty simple because HTTP is already so widely standardized. But in this example, I can consolidate all the logic that I know needs to happen for every HTTP call, things like JSON serialization or content type headers or authentication, and I can make it really easy for developers in the future. They only have to worry about things that tend to change between calls, like the actual URL endpoint or the JSON payload itself. And lastly, sometimes you go on a variety of speed dates and you're really looking for that one that can really change your life to start your honeymoon adventures with. But no one's good enough for you, and it's very frustrating, and you have to just build the thing yourself. So in my demo component, Grommet didn't have a card that I was super excited about, so I decided to just build my own really simple one. And the great thing about these custom components, because a lot of us already have custom components, they play the exact same role as a wrapper component. They live as that interface between the rest of your application and this particular piece of functionality, and I can standardize all the functionality that I want. So all of my cards have an image and some text. This is my cat. He's not adoptable. So I've gone ahead and put that here in my prenuptial contract. And if I ever uptake a third-party card in the future, this component is just going to become my wrapper component. I can switch out the render function as long as I don't touch the contract. None of my application needs to know. And what about testing, right? Because in my experience, very recently, sometimes the worst part about breaking up with a library is not only do you have to go and fix it, all the places the library was being used, but maybe you also broke, I don't know, like 500 tests. And maybe you have to go and individually fix all of them. And even worse, maybe there's actually some functionality broken in one of those tests, but you've put yourself on autopilot because you're trying to just get through these 500 test failures, and you might just glaze over the fact that there's actually something broken with your application. Now, I found that the key to writing tests that can survive the breakup is just to really make sure that we're not testing implementation details, because at the end of the day, your users don't care what library you're using, which kind of makes it an implementation detail, so neither should your tests. They shouldn't have to care. Here I have my button sidebar component. It's pretty simple. All it does is render 3 buttons with varying icons and labels and on-click handlers. And so I want to be able to test that these buttons render in the DOM and they behave how I want them to behave. One pattern that I found really helpful is to use test IDs as selectors, or the actual text of the button, or something that you as the library consumer have control over. So in this example, I have 3 button wrapper components, and I pass in a unique test ID to each one of these button wrappers. This test ID is going to get drilled through to the DOM via a data attribute, and I can use this as a selector in my tests. The reason being is because if you're using something like CSS class names or a particular DOM structure, these are things that are going to be incredibly tightly coupled to whatever library you're using, and that's going to make your tests incredibly tightly coupled to whatever library you're using. However, in my tests, I can use this test ID to assert on the DOM trigger click events and test everything that the user would need to care about without assuming anything about the button implementation itself. In these examples, I'm using a React library called React Testing Library. If you're using React and don't want to test implementation details, I would highly recommend it, and I'm happy to talk about any one for however long you have about how great it is. So I've decided that my application is going to be a huge hit because everyone in the Seattle area is going to be using it to adopt their pets, to discover their pets to adopt, and I need more features. And I'm going to opt for a component library that has more functionality because Grommet is on the smaller side, so I'm going to drop Grommet for Material UI. And I've also decided that Super Agent is pretty heavyweight. I'm making a pretty simple GET request to my server. I don't actually think that I need such a heavyweight library, so I'm going to break up with Super Agent. And I'm going to show you that live. So here's my demo application. Meet Kitty Toledo. They're adoptable. I can fetch random pets from my Google Cloud function as long as my internet tethering is working, which it's not. So that's cool. Let's try it one more time. That's really sad. That's okay, we saw Kitty Toledo. Meet Golly Gee Willikers. Maybe you'll see their picture soon. Anyways, the demo application, when it works, it's really cute. You can fetch random pets and they show up on the card. You can favorite those pets. We'll favorite their name on the right. And you can clear your favorites. My favorite feature of this site that's not going to work is when I click on this cat, it takes me to the Seattle Humane Society cat adoption page. Hey, Jess.
Hey. There's an internet.
Oh my gosh.
Yeah. Just so you can see the things.
This is the most important part. Let's see if I can fetch a random pet.
Come on, internet.
That's okay.
Okay. If you're still connected to your Wi-Fi, maybe block. No, you turned it off.
Let me try to connect to my hotspot one more time.
All right.
I know everyone is here just to see cool pets. I know I didn't advertise it, but now that I've told you, it's pretty important, right? Thank you. That's okay. It dropped connection right as I went on stage, which is always fun. Okay, anyways, you'll have to trust me. You get cute pets. This button takes you to the Seattle Humane Society site, and you can browse all of the really cute pets that you can use your imagination for. Maybe your next dream pet. So taking a look at the actual code, I have my button sidebar. These are the tests that I was showing off earlier. I'm going to run them just to prove that they work, because I don't need you all to trust me, except for with my site, because it's not working. Cool, so they passed, which is great. I have my button component here, and like I said, I'm gonna break up with Grommet because I'm gonna need something with a lot more features, so I'm going to use Material UI. Going to comment out the Grommet implementation, or the import, comment in the Material UI import. I'm going to comment. Sure. Cool. I'm going to comment out the Grommet implementation and comment in the Material UI button implementation. Again, like we talked about earlier, the insides of these components are ever so slightly similar, but you can imagine, again, speaking from personal experience, if you had a very complex application and you had, I don't know, like 400 buttons on your page, how incredibly infuriating it would be to have to go and switch out this button for that button and that button for this button and figure out all the imports, and it takes a lot of time. But I haven't touched my prenuptial agreement, the contract, so I don't have to update in the consumers of this button wrapper. I also have my API utility. It's using super agent right now, which frankly I just don't need, so I'm going to go ahead and comment out the super agent import. I'm going to comment out the super agent implementation. I'm going to comment in a native JavaScript fetch implementation, and then same with post. And again, these implementations are fairly similar because they're both just making a GET request to the server. But again, you can imagine if you had a really complex application that was making like dozens or hundreds of HTTP requests to the server, you wouldn't want to be that developer that picks up a ticket that says, go and change every super agent call to a fetch call. Nobody wants to be that person. But I haven't updated my contract, so again, none of my consumers have to be updated. And lastly, I have this custom card component. Material UI actually has a card component that's way better than mine, so I'm going to go ahead and use it. I'm going to comment in the Material UI import. I'm going to comment out my really naive implementation and comment in the Material UI card. This one is actually vastly different because I made a simple div, it wasn't very accessible. The Material UI card is pretty complicated though, because the way you build up these cards is Material UI gives you these child building block components that you build up and stick into the parent card and magic happens. You have to use a card media for the image, a typography to add text content, but I haven't updated my interface. This is a common pattern. I don't have to update any of my consumers, and the best part is that if you want to add a card to my app in the future, you don't have to go and figure out what a card media or a typography or a card content is. All you really need to care about is these three options, because I've already decided for you what cards are going to look like on my application. I'm going to go back to the button sidebar tests, and I'm going to run them because I just completely changed out the button that I was using on my page. But without doing anything except for switching out the actual library, my tests just pass, which is super great. And my app has been hot loading in the background, and you'll notice that it looks a little bit different because these are Material UI buttons now. When I click on it, stuff should happen, and you should get a Material UI card, and it looks a little bit different, but pretty much the same. And I can still favorite my pets with this card that isn't populated, and I can clear my favorites, and it's all really great, and you all just have to believe me. But when it works, it's really cool because I can completely change out the entire implementation of this demo app. I can change out the buttons, everything you see, including the buttons and the cards and how it's actually making API calls to the server. And everything, usually when there's internet, just works. So you'll have to trust me. It's awesome. But what does all of this mean for us? Well, for one, it means that breakups don't have to be messy. The JavaScript open source community, and maybe even your internal JavaScript community, is incredibly fast-paced, and we want to be able to remain nimble in this ever-changing environment without having to be so tied down to our past decisions, because we have to somehow explain to our product owner that it's going to take a month to replace all of the buttons to just be different buttons. And the other thing about wrapper components that I've really appreciated is that library opinions don't have to affect your code decisions. Every developer has different ideas and opinions on how they want their code to look, how they want to interface with their reusable code. But if you contain your library interactions into these wrapper components, you still have control of the interface, which is what the rest of your developers will have to care about. And it can be really difficult when you're importing in all these third-party libraries and you want your code to look a uniform way, but you have to do what the library wants you to do. So with these wrapper components, you can kind of protect yourself, give yourself a layer, so that you can implement it how you want to. So I hope you'll try out this technique the next time you have to uptake a third-party library or an internal library, and see if it can help make your code, see if it can help save your code from some really messy breakups like it has for me. Thank you. Thanks.